So look, here's a happy chappy. He was obviously happy on the day that he bought this light. I bought two for my kids over just a year ago, and both of them have gone wrong. Can you believe it? Hardly used at all. Terrible, really. And so this is the box. Look, it's one of these Philips Living Colours, 64 whole colours in a box. Light output 50 lumens. On product control, which means there's a switch, or you can change the colours. LED. So yeah, colour your world with light and so on. It's a Philips product. They're not cheap. You can freeze frame and have a look. But yeah, the problem with one of them's completely dead, and this one, just after you switch it on, after about 2 minutes, it starts doing this, and I'll show you what it's doing. Here we go. Here's the actual product. Can you see that? You see it lighting up and then off. See on my hand. It's strobing, but I can't see that strobing. That's just the shutter on the camera, the rolling shutter. But you can change the colours and everything else, but it shuts on, shuts down, then starts. So it's like flashing all the time. And it will do that ad infinitum, alright? So I thought, it's not working. So I put some proper power from my power supply up there, and it works fine. So clearly it's the power supply. So it's running on the Philips power supply module at the moment. I'll just pull out and show it to you. So this is the offending power supply. It's a Philips LED driver, and you can see that 5 volt, 1 amp, 5 watts. And the light is supposed to be 4.7 watts. So we're okay, we're consistent there. But this power supply, after it's been on for like a minute, it starts shutting down and opening up, going up and down. The power, after it's been on for 1 minute, the power keeps dipping out and then resetting and then coming back. The light isn't taking too much current, because I've checked it, it's taking 600 milliamps. So it's well within the 1 amp range. And so I did put it in the vise. I used one of these here vices like that, one of those Stanley third hand job, you know, when you've got hand jobs. Yeah, the swivel bit and that bit, and cracked it open and just clamped it closed and went around the gap, and you could hear it creaking and complaining, and then eventually a crack just opened up and I took it apart. Okay, so I'm just going to show you the gubbins here. You can see I had to lever a screwdriver in just there to get the lid off, but once the lid's off, this is what's inside. Alright, and along with the old adage, it's best to have a look before you get your scope probes out and everything else, is I had a damn good look at it, and I think I've identified what the problem is. Let me just go into telemacro for you, hold on. Right, so we're looking at the underside of the board now, and can you just see, where's my tweezers gone? There they are. I've discharged the capacitors. I'll just do it again to make sure. Let go of that one with that hand and just short these out, and there's no power in them. And we're looking, area of interest is just there. Can you see that short? And I'm wondering, I don't know where that is on the circuit. It uses the Viper 12A. It's an on-semi chip, 75p, 50-cent chip, probably 20 cents in volume. It's an integrated power supply chip, but they've got good separation here between the main side and the DC side. And you can see there's the opto-isolator, which feeds back the voltage. So it should in theory be quite a good power supply, but the fact that both of them, 2 out of 2, have failed in less than 18 months doesn't really bode well for the product itself. I'll have a look at the other one when I get round to it. My daughter's going off to move into a new flat, so she's asked me to fix this for her today. So I'm going to remove that short there. Can you see it? If I move closely, you might be able to see it better. I don't know if it'll actually, will it work? Yes, it will. You can see it just about there. So I'm just going to remove that short with the soldering iron and see whether this fixes the problem, or if I have to order a new chip. Interestingly enough, on the other side, if I turn the board over and let it focus, you'll be able to see what we've got here. It's a little bit close up, but you can see the mains comes on these 2 red wires. You've got your bridge rectifier. I am not entirely sure. It says F1 fuse on the board, and I'm guessing it is a fuse, but it doesn't look like a fuse. It looks like a PTC or an NTC. could be either. The NTC is usually used to stop inrush current. The PTC is used to go open circuit when there's an overcurrent situation. So I'm not sure what that is. I might look that up. Then you've got your two smoothing capacitors in parallel, a filter coil, a couple of components associated with the switcher. There's the Viper 12A. There's a smoothing capacitor for the DC supply for the Viper 12A. That could be a problem. They do go leaky sometimes, so it might be that, but I'm going to remove that short first, and then some resistors and class Y capacitor, opto-isolator. There's the rectifier diode, reservoir capacitor for the secondary side, and the feedback resistor and Zener to power this. So it's a crude voltage feedback based on that Zener to demand or less or more power. So this will be going on and off, controlling this, okay, and then obviously the transformer. But it should be okay. But in my experience, these one chip wonders like the power devices LNK 302, 304 range and this one are pretty unreliable. There's no real varistor in this. There's nothing to stop the voltage unless they put a varistor there. Is that in series with the power? No, that is actually in series with the power, so it's either a fuse or a PTC. I'm not sure which. I'll check it out. But I'll put the data sheet for this thing up in a minute. You can have a look at it. But I'll remove that short and see if it fixes it. But at the moment it's not the actual light itself, it's the power supply. So in one moment I'll just remove that short. Put my iron on. Put my transformer on. And we're just going to hit her with a bit of flux. This is the really good stuff. You could tin, solder anything with this, and it's well worth it. Just for a general everyday electronics, about $4 or $5 a pot delivered to the UK. And it looks like this. It looks like Vaseline, but it's a lot greasier. And it does a lovely job. So if I just take a little bit out, dob it onto this joint where the short is, there. So when I reflow this, it'll go all lovely and shiny and all creep back where it's supposed to be, rather than hanging around on the joint where it's not supposed to be. Let's face it, these days they've got automatic inspection and AI systems which have been around for years, so they should be able to stop that happening by now. Okay, let's try that. One moment. Yeah, that fixed her. It's interesting, isn't it? That joint must have just been expanding when it warmed up and just shorting out slightly. I'm going to investigate and see where it is on the circuit, but I thought actually you might be interested in the product. If you look at the product itself, you've got this colour strip, you've got on and off here, and you hold it. In theory it goes off if you hold it. Does it? It's interesting, isn't it? When you're holding on to it, it won't do it. You have to put it down. Just try this and then touch it. There you go, so it works that well. Is it? Maybe when it's upset it slightly, I think. Colours still work, but how do you turn it off? There you go, so you touch it. It's not a bit hit and miss. I think it's because I've been handling it, and this is one of those touch sensor ICs and they calibrate themselves constantly. So anyway, it's off. You can see it's off there, and it's working. So that fault is fixed. I'll just turn it back on again. But if I turn these lights off and shine it on Her Majesty, you can see a bit more about what's going on. So you can do all sorts of colours. Look, you can go like that. You can go around to the green end of the spectrum. Go to the pink, purple, blue, and so on. Yeah, so that repair has fixed it. So I'm just going to have a look on the circuit and see what was shorting, point it out on the circuit diagram for you, and then glue it back together. Then she can go off and move into her new house. So job done. Turn it off. There you go. So power supply fault. Obviously don't open these power supplies up unless you know what you're doing, because you're going to get a nasty shock otherwise. Let's turn the power meter off. Let's take the unit out. I'll just do a bit of Sherlocking on the data sheet and the circuit and tell you where it was shorting out. One moment. Quite a good name for a chip, don't you think? Viper 12A. Sounds like something, it should be really sexy. So it's 260 kilohertz, you can see all that. Yeah, basically a very low cost chip for making an offline power supply. In fact, but this one is not an offline power supply, it's a transformer, so they put, instead of the buck regulator inductor, they put a transformer instead, which is a perfectly valid thing to do with a feedback circuit. There's a feedback link there. So let's just scroll down and have a look. You can look this up if you're interested, but where's the circuit? If I can find the circuit, I know what was shorting out. Right, so what we had on there was an intermittent short when it warmed up between, let's just make this a bit bigger in case you were looking on a phone. Move it over a little bit. Yeah, what we had was a intermittent short. You can see this snubber diode, the transformer primary, and then the switch into the high voltage FET that was intrinsic in the Viper 12A. It was a short between that point there and the drain there. So that diode was being shorted out, and I'm guessing it just, because you had a ridiculous amount of power being drawn through that capacitor in terms of an AC transient through the drain, it was just overcurrent and shutting down. But it's fixed it, removing that short, but it can't have been a permanent short. It must have just been expanding slightly and making it short out after a while. But it's been going for some time, so it's all fixed. I hope you found that interesting. I'm just going to glue the thing back together, and as I said before, don't use these or power them up out of the case unless you know what you're doing. But the chances are, if it's not that, usual culprits are going to be these caps or this cap here or the actual device itself. Right. So generally speaking, they're very low cost power supplies. Are they worth repairing? Well, financially no, but it does stop something having to go into the tip, let's face it, into the landfill. So in that respect, I'm quite satisfied, and also she's happy. But I thought you might find that interesting, how the poor quality of the power supplies are really letting these expensive products down. It's probably a $1, $2 power supply. And I don't know about you, but I'd rather pay an extra 50 cents or $1 and have something that lasts 5 or 10 years. I mean, the pound shot battery USB chargers from the Poundland would work fine, and they're perfectly good. I've got a number of those. They've been going for some time. Trouble is they've got the wrong plug on. So yeah, I hope you find that interesting. If you can, then subscribe to the arrow down in the bottom right hand corner of the screen. But if you've got one of these, try a new power supply before you actually write the light off, because it's probably the cheapest and easiest way to get this fixed. Because I'll check the other one and I'll let you know. That's me signing off.